In the last 10 years, power plants have significantly changed their approach to preparation, as there were not many options to stockpile excess energy until recently. Nowadays, there are a vast number of different types of power plants, and although they are indeed impressive, their cost can be quite high. There are small models priced at a few $100s, and there are larger ones, like my unit behind me. This is the Avery model, and it's one of the most affordable. It costs $700. There are more expensive options like Jackery. Today I want to discuss ways to save money without buying one of these power stations, and what we can do ourselves. Here, the Life P4 battery comes to the rescue. This battery has a capacity of 100 amp hours, equivalent to 1,280 watt-hours. The type of battery you choose for preparation is not as important as if you were using it daily, for example, in a motorhome. In preparation conditions, this battery will be used in emergencies, and often it may just lie on a shelf. Therefore, the brand you choose is not as critical as in other cases. This is the Go Kilowatt Hour battery, and it is quite affordable. It has a monitor on top, which is convenient in the discussed situation, as it allows tracking the charge level. There are other models, such as Redodo and LeTime, that are also suitable for preparation. Another advantage of Life P4 batteries is the latest and safest technologies. Inside them is a battery management system that protects against overheating and low voltage, preventing damage. These batteries have a very long lifespan, which is why more affordable options are quite suitable for preparation. They won't break down a day or two after purchase. Although, theoretically this is possible, the lifespan of these batteries is likely to be shorter than that of more expensive ones. However, in preparation conditions, this is not so critical, as you prepare for disasters and want to be sure that your equipment will work. This battery will provide you with energy for a certain period of time, perhaps not as long as more expensive options, but it will be quite satisfactory for your needs. Life P4 batteries are excellent and the best in such situations. Today, I will talk about ways you can use this battery to achieve the same results as with a power plant. The first method is using an inverter. There are various power ratings of inverters. This inverter outputs a pure sine wave, which is probably suitable for you, but is not always necessary for devices like fans and lamps. However, for sensitive electronics, it is advisable to use an inverter with a pure sine wave. Mostly, you just take this device. You can have crocodile clips like these, or you can connect it to the battery using terminals like these, and just plug it in. But for the purposes of this video and to quickly start something, such clips will do just fine. Although they are not as efficient as a reliable connection, you see that you just plug this in here, and it turns on, and you are ready to work. This battery also has an app. In addition, it has an indicator that shows how much energy it consumes. At the moment, the current is 2.5 amps. The battery charge is 57%. There is information about the temperature and other convenient data that is usually available at the power station. I have a battery monitor connected at the station behind me, and at the other one, a Victron A. This is a convenient and easy way to get some AC power. There are several AC outlets here, and it's the same as at a regular power station. As for DC sources, you need to take a connector like this, a cigarette lighter connector, and connect it to the battery. Let's do this right now. Just screw them in here. It's also worth mentioning that there is a 20 amp fuse installed. These elements should also be protected by fuses to ensure safety. We don't want to create a fire hazard. These batteries have all the necessary protective mechanisms, but for additional safety, it's better to install a fuse here. Now this will provide you with direct current. We have an inverter that provides alternating current for lamps and other things, but you also need direct current. You can buy an adapter that costs about $10 and simply plug it in here. This small adapter, I will leave a link below for it, will show the battery voltage. For example, it currently measures 13.2 volts, while the battery monitor shows 13.3, so it's quite accurate. With this adapter, you will have the ability to connect several USB and USB Type-C devices, depending on what you have. Another thing that might be convenient for you to do, which will save costs, is to leave this DC converter connected. You also have inverters, like this one from Bestech, which is very convenient as it plugs into the cigarette lighter port. You can take this inverter, turn it on, and you will have electricity. Moreover, there are several USB ports here. However, keep in mind that when using the inverter, alternating current will consume more energy than direct current. We will discuss this in more detail later. It is also important to remember that the ports for cigarette lighters have a power limit. You can use about 200 watts. This 20-amp fuse corresponds to about 200 watts. The power of this inverter is 300 watts, so it is not recommended to use it at full capacity, otherwise the fuse will burn out. If you have small devices like lamps or fans, you can use such an inverter for tasks. It is best to try to avoid using alternating current when possible to save energy. Inverters consume a lot of energy that could be used for other purposes. For example, I have a direct current refrigerator that I connect to the direct current port. It uses about 50 watts and consumes approximately 300 watt-hours during the day, which is very little. For alternating current, these figures would be significantly higher. Therefore, if you have devices that can run on direct current, connect them that way. It will save you a lot of energy. Sometimes this may be impossible, and you will need lamps or other sources of light. In that case, you can use alternating current with inverters. It is also worth noting that inverters come in different sizes. A 1500-watt inverter will consume much more energy than a 300-watt one. The brand also matters in terms of efficiency, so be sure to study inverters to ensure you are using your energy wisely. If you are just starting out and want to save, it's not so bad. This is one of the advantages of this approach. You can assemble a system piece by piece instead of spending $700 or $800 on a single purchase. With portable power sources, you can buy a battery for a few hundred, an inverter for $100, and additional connections. $10 here and there, and you can piece it all together. Over time, you'll have the entire necessary set. This is actually a more feasible way to organize electricity supply than using a stationary power plant. Of course, stationary power plants look attractive and convenient, but they often have a lot of wires. However, you can build your own portable power source. I did it myself. I have a source in my garage that is currently used to power my motion sensor lights, but I also have an inverter. I assembled it just like a stationary power station because in case of disaster or emergency, I can turn off these lights and use the power source anywhere, as if I had a stationary power station. You can take a container or something similar and just gather everything you need in one place, so it's ready to use. As I mentioned, these crocodile clips allow you to quickly connect an inverter, turn on the light or fan, everything you need. Considering all this, it is worth noting that the details can be quite expensive. And in the end, you may spend almost as much as one of the cheaper power plants. However, the advantage of this approach is that if something breaks, and you buy one of these inexpensive power plants for $600 or $700, sooner or later, it may fail. Something inside it may malfunction. If you buy a few inexpensive components, in case the battery or inverter fails, you can replace the inverter for just $100 instead of $600 or $700 for a stationary power station. If the battery fails, you'll spend a couple of hundred instead of $600 or $700. Another advantage is that you can expand your system. For example, you have a LiFePO4 battery with 280 watt-hours. If you want to increase the power to 2 such batteries and reach 2,500 watt-hours, you can do that. From one of the stationary power plants, you will be limited to what you have unless you buy additional modules, as I did. I will talk about this in the next video. I want to emphasize that you have many options if you choose this path, and you can start with 3 basic components: a battery for $200, an inverter for $10 to $20, a total of $220, and you already have a source of direct current. For $50 to $60, you'll get a bit of alternating current. For $300, you will have everything you need to provide both alternating and direct current to keep mobile phones charged, turn on lights or fans, and be able to charge devices in case of disaster or emergency. You will be ready for any surprises. Another point that I am not going to delve into in this video is solar panels and charge controllers, but you can also do this. You can buy a charge controller, a solar panel, and connect all of this directly. This is more like a battery system, where you assemble a setup that will work like a power station. If you want to maintain the charge, you have several options. For example, there is a small charging device called a tracker. I think its power is about 2 amps. I use it in winter to maintain the battery charge of my lawnmower tractor. If needed, I can plug it in. This device can be left connected to the network, and it will constantly maintain the charge. There are also chargers for 10, 20, and 30 amps, which are also suitable. This is a 10-amp charger for lithium-ion batteries, and it really heats up. Therefore, it should not be left plugged in constantly. However, it allows for charging the battery much faster. In case of a power outage, you are unlikely to have the ability to charge from the grid. But if you have a generator, you can use it to generate AC during the day to charge this battery, and at night use it in silent mode. If you have a generator or inverter, such as the Predator 3500, you should choose a charger with a power of at least 30 or 40 amps. At 10 amps, charging from 0 to full takes 9 or 10 hours. At 20 amps, it takes about 4 to 5 hours. Therefore, if you manage to charge it in a couple of hours, it will be the best option, as you will spend less fuel. The higher the amperage of the charger, the faster it will charge the battery, especially if you plan to use it that way. If it's affordable for you, it's also convenient for everyday use, as you can quickly recharge the battery in a couple of hours. Otherwise, if you just want the battery to sit on the shelf waiting for its turn in an emergency, this little tracker for $20 is a great option. Just keep it charged, and everything will be fine. Thus, these are just a few ideas for those who cannot afford a generator or are still saving funds. These batteries are completely safe, much safer than lead-acid or marine batteries, which we often discussed in the context of preparation. They can be stored indoors. You can keep them on their side. In general, you can arrange them as you wish, and it won't harm the batteries. It's really nice, as they are suitable for storage and other needs. The battery management system and all safety features make these devices ideal for preparing for various situations. They can be used indoors. Essentially, these are the same components as in stationary power plants, just presented separately and slightly larger, but functionally, they are the same. If you don't want to spend large amounts on a stationary station, you can buy a LiFeP4 battery, 1 or 2 DC outputs, and an inverter, as well as a way to charge it, and you'll be ready for any emergency. As I mentioned, I have my own battery bank that I assembled to avoid spending $1,000 on an expansion battery for these stations. I made it myself using several LiFeP4 batteries, and in the next video, I will explain in more detail how I assembled it. This works just great. The video will be released in a couple of days, so stay tuned for updates. If you have questions or comments, feel free to leave them below. Take care and prepare for different situations. Hope to see you in the next video. Goodbye.